All right, welcome to the ROBOZE and CAD-CAM Consulting Services webinar. It is July 23rd, 9 o'clock Pacific. We are ready to get started. Before we begin, just a little housekeeping. This is scheduled to be a 1-hour webinar. If you have any questions, please type them into the chat function in Zoom. We'll be sure to address them all by the end. We might wait until the end, but if it's something incredibly relevant to what the presenter is showing, I might hop in and ask them to take that question. Axel and Levi, you're also welcome to answer those questions if you're not presenting in the chat. But also keep them appropriate. Everyone can see them. We'll do a little follow-up at the end if you're interested in what you've seen today with contact info, how to get a hold of us. We're recording this right now, so it will be available in the next day or so. We'll put it up on our YouTube page. We'll send out an email to all those that registered and or attended. And then we're going to do our best to keep you muted and keep your cameras off. But if that changes, we just ask you to stay muted and have your camera off on your end. So today we're going to talk about the ROBOZE. ROBOZE as a company, the ARGO 1000 HYPERMELT, and kind of how we operate in that space. We'll do a little closer and a recap, and we'll have some questions at the end. So why are you here today? We really want to show you how 3D printing can benefit traditional subtractive shops. Can you realistically use plastics and super polymers to replace metal, what you're currently using? And how will the ARGO 1000 HYPERMELT complement your existing processes? It's not there to replace them. So speaking today is Axel Fernandez, the additive manufacturing lead at CCCS. We have myself, Graham Hargraves. I'm the strategic business manager, and Levi Smith from ROBOZE, Global Director of Channel. So thank you guys for joining us. Little quick rundown on who we are. If you don't know, we've been around since 1993. We've served the Southern California and surrounding areas with additive, subtractive, and inspection, manufacturing software, and hardware solutions. So what are those products? For additive, we have desktop metal, 3D printers, and ROBOZE, what we're here to talk about today. For subtractive, we have CAM Assist and MasterCam. Also, MasterCam Probing, which was formerly Simco. They were just acquired a few months ago by MasterCam. Also, Mold Plus and Vericut. And then on the inspection side, we have VeriSurf. So as a company, we're local to you in Southern California. We are experienced. We have an incredibly tenured staff. They're dedicated. We have 3 different offices throughout Southern California: Anaheim, Newbury Park, and San Diego. At all of those locations, we provide training support, on site, but also we host online training that's running throughout the year. So if you're interested in training on any of these products, let us know. The majority of our training is conducted through MasterCam, with MasterCam as the flagship product, but we are certainly there to get you up to speed on anything else. So in a nutshell, we know the local community for manufacturing. It's our goal as a business to make your business successful. We've been playing around with this idea called closed loop manufacturing for the past year or so. It's a process of taking all the products that we represent with a single file and moving it through the entire manufacturing cycle from design to completion. This is a unique and efficient way to do this, and it's actually real world tested. So before we wanted to start talking about this concept, we needed to prove it to ourselves first. So we took an existing part, which was a putter head, which you can see in between those little balls on the table. We reverse engineered it by scanning it into VeriSurf. Then we said, okay, this is a completely or a very complex shape. Let's 3D print this thing with desktop metal. So we printed that in stainless. and then it needs to go to the CNC machine. How are we going to hold this part? So we designed some work holding, some fixturing with ROBOZE, and that was able to hold the part very easily, not mar the part because it was a super polymer as opposed to metal. And then that's what it kind of looks like in Mastercam. So we went in, we can use Cam Assist to do some quick programming on this, touch it up in Mastercam. For this part, it was really, the bottom of the putter, the engraving, and the face of the putter. Then before it hits the machine, we want to make sure that it's going to run exactly how we want. So we simulated that with Vericut. And before, during, and after the machining, we had Mastercam probing, make sure it's located, it's going to cut the right part, portion of the part, and we're good to go. So after that was done, we brought it back to Verisurf and inspected it to make sure that it was within our spec. Then, of course, we had to do our own R&D and bring it to the golf course. This putter did not make me a better golfer, but it was very fun to use, and I can, as an avid golfer, it works very well. So these are all the products that we offer. If you're interested in the process of this, we did a 4-part article series on machinedesign.com. So if you go to machinedesign.com, you click the search up in the top right, which is highlighted in orange, and type in putter in the yellow, you'll see these 4 articles, which are shown on the screen here. So go and check those out. It's a very interesting story. And that is it for me for now. I'm the bookend of this presentation, so I'll be back in a little bit, but I'm going to turn it over to Levi.
Terrific. Graham, I appreciate just the introduction there. And just before we kind of get into ROBOZE, I always like to start with, who are our partners? Why do we choose them? As the global channel director, it's my job to kind of evaluate, vet, and find the right partners for us. We have a limited ecosystem. We do that on purpose because we're looking for the right fit, people that can extend our approach, whether that be go-to-market or just expertise into specific markets. And, CAD-CAM really fits the bill in all the ways that we are looking for. So they are our representation in California. Very excited to have them on board with us. You can just see by the average tenure of the team there. They know their products. They know the territory, the customer's pain points. I think the best part about our relationship is all you have to do is go to CAD-CAM with a potential engineering problem, and they're going to deliver an agnostic solution to it. So it's a pleasure to be working with them. And Graham, can you move next slide? So I'll start with just, who we are, what we're about. I wanted to kind of start with, kind of the bread and butter of the presentation today, and that is, our additive manufacturing platform, right? What we're really going to be talking about today is the ARGO 1000 HYPERMELT. This is our newest and latest edition. Obviously, we have the ARGO 500 on the screen, the Plus Pro. The Plus Pro you can find and evaluate in-house in Anaheim with CAD-CAM. They have one of these running. So they definitely have our products in-house if you want to have a demo. But today, again, largely, it's all about the ARGO 1000. Next slide, Graham. So, at ROBOZE and just traditionally in the additive manufacturing, world, we always like to think about our products, not just the printers themselves, but the ecosystem around them, right? We have high-end, high capacity, high production industrial equipment, but that is just one aspect of it. So, we are just as much a materials development company as we are a hardware manufacturing company. And that also includes, obviously, the software we develop to make sure that we are producing successful builds on our platforms, and of course our services. So we do offer a range of services in terms of evaluating our products in-house, from material development to a lot of other really exciting ways that we kind of collaborate with our customers. So it is an ecosystem over at ROBOZE. I think that's key. Next slide, Graham. So just a quick kind of history dive on ROBOZE. We've been around for a decade. We originally were founded in Bari, which is southern Italy. That is our headquarters. Our founder was essentially enamored with this technology in terms of 3D printing. But he saw some limitations. One is repeatability. Why can't I repeatably produce parts at the same way with my milling equipment? That was a key component for him. The second is why are we using, some of these kind of standardized low melt temperature plastics? And so those are two of the key factors that kind of came to him and he thought about when he built ROBOZE was how do we do the craziest materials possible, whether that's a peak, a carbon peak, an Ultim. Some of the materials that we're still developing in-house are just, we're not going backwards. We're actually just at the edge of what can really be created. So we wanted to create a machine that could be repeatable, but also produce some of the most difficult materials to produce in a 3D printing process. So that's just a quick snapshot. Our headquarters in the US is Houston. I'm based, of course, on the East Coast in Boston. But I just want to give you kind of just a short history of who we are. Next slide, Graham. So, in terms of these materials that we work with, I touched on this earlier, we are just as much a materials development company as we are a hardware platform or a hardware manufacturer. And some of these materials that we work with, whether it's a peak, a carbon peak, or an Ultim, yields a specific industry focus on our products. So these are the main industries we work within. Oil and gas is a huge one for us. We tend to essentially segment into highly regulated environments based on the materials we produce on our machines. So in oil and gas, a lot of people are looking at metal replacement components. They're looking at anti-corrosion or applications that can sit in highly corrosive environments with lots of pressure that require a lot of strength. Aerospace, they're looking at a lot of lightweighting, right? A lot of essentially flame retardant material like an Ultim, but also in a very lightweight capacity. So really saving weight with regards to the components that they build in aerospace. Mobility continues to take off. We see a lot of tooling applications in the space. Same thing in industrial. But really what we're also seeing quite a bit of is essentially supply chain concerns, right? Around some of these exotic materials like PEEK. They're incredibly difficult to source. And there's a lot of pressure on the markets to source these obviously efficiently and cheaply. And this is where we come into play very well. Next slide. So when you think about your environment, the parts that you're creating day in, day out, really this is just a good guideline for parts that fit really well within additive manufacturing. So if you look at the graph, obviously the sweet spot is what we call the slow movers. High lead time, low number of component parts. Obviously, they're usually incredibly expensive. You're working with potentially a new relationship. There's usually a lot of friction with trying to source and produce these parts. And this is where we play incredibly well. And we do it at scale. So, the machine that we're going to be talking about specifically today is essentially a meter cubed in terms of build volume. So think about anything within a meter cubed in terms of an application. That is what the ARGO 1000 is built to do. And we'll really kind of touch on how we do that as well. Next slide. And I'm going to continue to go back to this point as we continue through this conversation today. But what I wanted to kind of showcase on the machine is our traditional, or on the screen here, is the traditional materials that we work with that are compatible with our printers. The six on the right are really our bread and butter, right? The PA Pro, Carbon Peak, Ultim, Peak, PEC, Tooling XCF. These materials are delivering a tremendous amount of strength. They're also delivering, corrosion resistant. They're very inert. And they fit a lot of the certifications that people are looking for, whether it be mobility and railway or V0 certification and smoke and toxicity certification, or just, corrosion resistant, right? We're traditionally using metal. I have to replace this in a couple of months. It's a lot of work. It's a lot of money. How do I get the longevity of this part up to something that is really acceptable within our environment? So just to give you a snapshot of the materials we work with, these materials are incredibly difficult. They can be somewhat nuanced in terms of how you produce them in a repeatable fashion successfully. And that's what we've really spent a decade perfecting with our ecosystem here. Next slide. So just to give you a snapshot, I always like to touch on this because, we do a lot of metal replacement, but it's not just strength. What we kind of see with our customers, with the applications that they bring to us is traditionally, historically, with that application, they went almost 100% to just strength, right? The strength within that application with that metal that they're using is overkill. It's just too much. I don't need that much strength or that much tensile strength within this application. We're usually looking at a combination of things. One is obviously strength, right? Does it match where I need to be? Corrosion resistant. Is it inert? Can I put it in, a downhole tool for an oil and gas well without having to replace it every month? And they're also looking at the ergonomics. How light can we actually make it? And this is why we do so well in some of these industries that you'll see, whether you go to our website, whether you go to CAD-CAM's website, right? We work with a lot of Formula One racing teams that are really looking to get as close to that engine in a critical application as they possibly can and make that part as light as possible, but still fill the strength requirements that they need to make sure that part can function successfully. So it's a combination of these things. And up on the screen, you have a series of different parts from, Carbon Peak to PA Pro to Ultim. On the far right, you obviously have our materials against aluminum 3031 in terms of tensile strength, in terms of density. PA Pro is really a bread and butter material for us in terms of both its strength, but its strength to weight ratio. And that's why people choose Carbon PA Pro all the time. Ultim 9085, it's all over the aerospace industry. They're constantly sourcing new and new applications and vetting new applications to be replaced with 3D printing. Next slide. And today, what we're really talking about, and what we're really excited about here is the ARGO 1000 HYPERMELT. Again, this is the largest pellet-based extrusion system that can produce high temperature composites and thermoplastics. So it's the largest one out there. You can see, obviously, just some of our customers below. But again, meter cube, you want to print a large Carbon Peak part, a PA Pro part. You have the capacity to do that. And I think what's really exciting is the fact that we are moving away from filament-based FFF extrusion to pellet-based FGF extrusion. And again, this is a unique thing that we did. This product has been in development for years, right? We were really looking at just another filament-based FFF large format printer. And as we got into the R&D and just the development of this product, what we really saw was the business units didn't really line up, right? If you're using filament, it's still incredibly slow, and it's still incredibly expensive. And we'll touch on those two things today. But the ability to produce a massive sealant ring in peak in under 4 hours is very, very unique to the ARGO 1000. And we'll touch on exactly how we do it. But, when you start working in pellet and when you can produce, close to 2 kilos an hour in terms of a part, the business and unit economics really, really become very exciting. Next slide. And what we coined our IP over here at ROBOZE is HYPERMELT. This is our FGF technology, our pellet extrusion technology. And we took a look at the market. And what we were really looking for is something that was, essentially missing from the market in general, right? Where does filament-based extrusion sit? And where does LFAM, large-scale additive manufacturing sit? And HYPERMELT sits right in between that. What we're looking at is the broadest range of applications for productivity and surface finish. And we'll talk about the specific things that we do within our industrial equipment. But really, what we are able to kind of harness is pellet extrusion that is creating surface finish results similar, if not exactly the same as what you see with FFF printing. And so it's really exciting what that kind of represents because it represents a cost per part reduction, a productivity increase, and results that you're really going to see from a traditional FFF or FDM printer. So next slide. In terms of what those surface results look like or surface finish looks like, this is a great example. So this is just a traditional ABS red. Again, this is a enclosed precision environment that we are printing pellets with. and it yields a terrific surface level finish. So, whether you're just doing a lot of production prototyping, you're going to get results that are very similar to what you're currently getting. And I think another key difference is the volume, right? You can do massive parts up to a meter cubed, and we're printing at close to 2 kilos an hour. So, I mean, we're printing these parts within 2 to 3 hours. So being able to turn these around, if you look at traditional large format with filament, this could be, somewhere between 24 and 72 hours, depending on what material you're using. With us, we're getting it turned around in half a day with that type of surface finish. So again, production, cost per part, surface finish at large volume, which again, very exciting. Next slide. And I wanted to do just a quick comparison. This is, on the right, you're going to see our essentially pyramid of materials. Again, these are materials specific to pellet extrusion with ARGO 1000. But what I did was I just kind of took our traditional filament MSRP cost and compared it to our traditional or our current pellet costs, right? So this is just material and MSRP per kilo, but you can see a substantial reduction in cost. So whether you work in a high-end material like PEEK or carbon PEEK or just a traditional standard ABS, you have tremendous economics with regards to using our printer to produce the parts you need. Really, what it comes down to is what is that application? What is that geometry? Is it feasible? Right. And I think this is a key takeaway I want everyone to have today is if you have a need, talk to Axel, talk to Graham, talk to Patrick, see if you can send them a file and say, hey, what would this look like? What would be the business case, or how much would this actually cost, and how long would it take to produce if it was produced on the Argo 1000? We see anything above, essentially 400, 15 by 15 inches tends to be, the parts are not too crazy in terms of complexity, but they're still incredibly difficult to source. And so, we have a real value add when you start producing it in pellet. Next slide. So just some specifications on the machine. I wanted to give you guys just this quick snapshot. Again, it's a huge, massive machine. We were at Rapid with the Argo 1000 2 years ago. I know I think Axel and Graham got a picture in front of it. I mean, it's a tremendous machine. It's about 4,000 kilos. The extrusion is going to get up to 450 degrees Celsius. This is to really work with our semi-crystalline materials like PEK or Ultem or Carbon PEEK. But we can also work with traditional low melt temperature plastics like ABS. And that environment is 180 degrees Celsius to get, fully uniform components with regards to a PEEK or, an Ultem 9085. Next slide. The real engine of the Argo 1000 is our essentially our extrusion, which we essentially built from the ground up. This is about 2 years of R&D. When you think about extruding pellet, I think the best way to think about it is a traditional pellet injection molding machine, right? So essentially, we feed the pellet into this extrusion nozzle. It's got three specific heating zones. As it winds its way down, it hits the precise melting temperature before it hits the extrusion component. It's equipped with liquid cooling. It's got a three-stage component for getting the precise temperature of that pellet before it is actually extruded. It comes in three different nozzle sizes. And you can see the capacity at the bottom there. That is very much a conservative estimate. We're still seeing upwards of 3, 4, 5 kilos an hour in terms of extrusion, but this is good and conservative. And it comes with a series of different nozzle sizes. Anyone that's familiar with FFF printing, the smaller nozzle size will add a little bit more precision, a little bit of surface finish. Obviously, you can go for just production. If you just need rough production prototyping or in-use parts, you can get up to 3 millimeter nozzle sizes. So it really, I picked the middle ground here. Conservative estimate is we're going to print at 2 kilos an hour, which again, if you look at traditional FFF, you're looking at, maybe 1 kilo a day. With us, it is a substantial increase in production capacity, and that's all based on this engine we built from scratch. Next slide. The Argo 1000 is a dual extrusion printer. It's independent in the X. We do share the YZ. We have the ability to do batch production, so it has dual print mode. So even if you have smaller applications, you can run batch production. We'll have two extrusion nozzles to help with that. It also is very complementary in terms of handling support materials. So, in terms of, if you're using Ultim, you need breakaway support, you have that capacity. If you're using maybe, PA Pro and you need dissolvable supports, it does support that as well. So, again, dual extrusion is part of the Argo 1000. Next slide. And you'll see this IP on our range of printers, whether it's the Plus Pro to the Argo 500. The Argo 1000 is equipped, and this is kind of the backbone of our technology, is we have a patented beltless system, essentially a hardened rack and pinion system, very similar to what you see in CNC industrial equipment. It provides mechanical repeatability, but positional tolerance at extreme levels. So the second you start producing that part, it's up to spec. You'll be able to repeat that across machines. If you scale out to more than one, you're not going to have essentially just a series of different parts, even though it's the same build. So again, this is also great with regards to production capacity and maintenance. Traditional belted FFF systems, you're constantly having to maintain that belt and the tension within it. With us, essentially, you just have to grease up the rack and pinion once a month. So there's a very low level of maintenance with regards to making sure that environment is up to spec. The PLC, or the programmable logic controller, allows essentially a central brain within the printer. So this is great with regards to the aerospace sector that needs to track essentially the lot number of the material all the way to the build. It's going to produce a dedicated print report per build. So whether you want to see if there's under extrusion, over extrusion, you have that capacity. I think an additional added benefit is just the robust nature of these machines, right? We expect these machines to last 15, 20 years. And if you look at the 3D printing space in general, it's usually a microcontroller unit that is the central kind of brain of that printer. And essentially to get the newest and latest components, whether it be the firmware, the software, or any of the new features that are coming out later on, you have to upgrade to the next new printer. With us, it's an upgrade package. So you can have the same kind of chassis, the backbone, when you buy an Argo 1000, and be able to consistently upgrade the hardware over and over again versus having to buy the next latest and greatest machine. The 3D printing space tends to be sort of works off of, you can consider it more like the Apple model. Every 3 years, there's a brand new phone you have to get. With us, you can upgrade your machines consistently as our product matures on the market. The last component, again, you'll see this in all our industrial equipment, but we have an insulated heated chamber. It's got over 12 sensors to control heat, gets up to 180 degrees Celsius. Anyone else out there that has a heated environment, they tend to have a linear heating element, right? It sits on the left, sits on the right. If you're working with Ultim or you're working with Peak, and you got a large application, it tends to have it's not a uniform chamber temperature. And with us, based on the way we've set this up, you can kind of see the little holes on the left and the right of that build chamber. It creates a vortex that allows the air to be completely uniform from left to right, top to bottom, front to back. So if you're working with a semi-crystalline material, you're going to have a uniform part at the end of the build. So again, we have a very precise environment that we've dialed in. Next slide. And so, with that said, really, I wanted to just showcase some of the parts that we see, right? In terms of surface finish, you can see on the left, I believe that is PA Pro, but just a monster build. On the right, we have these Peak sealant rings. These are going after every oil, essentially our market in oil and gas is, the tier 1 to tier 3 supplier who are supplying these parts in the oil and gas market. But sealant rings in inert material like Peak are huge. These rings are printed in under 3 hours and essentially are ready to go out in the field, which is, again, very exciting. These used to take weeks to mill. And that's if you actually had the billet large enough to mill that part. With us, we're printing these in less than a day. Next slide. And so just a couple of other, additional examples, really what I want to showcase is just surface finish here. These are obviously tooling and sealant rings in carbon peak, but you can see the surface level finish. You're getting very similar to what you get in a traditional FFF or FDM printer. Next slide. And I think the last component, and I'll walk through these real quickly, is the machinability. When you work with a PA Pro, a carbon peak, and our customers come to us on a regular basis with this, the machinability is crucial, right? Can I get to 90% of the specifications for this application and then maybe mill out the last 10% to get to actual specification? So in terms of our materials, flaking, delamination, melting, how you traditionally run your mills, if you want to turn this into a hybrid subtractive operation with the Argo 1000, you absolutely can. And that's an application we're having a lot of success. There's a lot of folks out there in oil and gas who just carry massive warehouses of peak billets. And based on the way we extrude, we can get essentially near injection molded billet finished. Essentially it's the near net shape market, but we're able to essentially build to specification people's warehouse of billet inventory. And we're able to do it in a way that they're not having to subtract 80% of that billet to get to their actual specification. They can just additively build it with a HYPERMELT Argo 1000 and then machine out the last 10%, really saving them a lot of inventory costs for sure. Last slide. And just kind of showing what a machine surface finish looks like. Again, this is I believe it's our 3 mm nozzle, so obviously the surface finish. It's definitely, you have a bigger extrusion component, but in terms of, having a completely filled, to specification, the ability to machine our materials is one of a kind. It truly is. So a lot of people are exploring a series of different applications and looking at the Argo 1000 as an inventory tool to produce on demand specific near net shape parts for customers who are looking for, machined final application. So again, there's a range of applications we are currently engaged with. This is one of them. But again, really exciting in terms of what we're able to produce. So I think that's the last slide, Graham. And again, I'll be available for questions. So on to you.
Yeah. Thank you, Levi. Yeah, just a reminder, if you have any questions, just pop up in the chat and type them in. We can answer those as we get to them. I'm going to pass it over to Axel now to handle his portion.
Thank you, Graham. Thank you, Levi. Yeah, this section of the presentation will jump into what can you actually 3D print on our machines. Levi already covered an application for sealant rings. So next slide. I would like to talk a little bit more about the project that we work on, the 3D printed work holdings. So I believe Graham just touched a few points on how we use all our softwares that we sell at CCCS to make this product, but I'll jump more into what exactly this was. So we 3D printed the golf putter using our metal 3D printers, but we actually had to machine it down to spec so that it could fit correctly onto the rod. And also we wanted the surfaces to not be, grainy, because metal 3D printed parts come out of the machine a little bit grainy. So we were able to design this work holding, which would traditionally be machined in aluminum. And, that could definitely work because that's how everything is being done. But we thought that, if we could just 3D print this part, we could save up CNC time, right? And now if you have to actually do that, the 3D printed part should be comparable to your aluminum part. So if you go to the next slide, you'll see that we use a super polymer over here. And this super polymer was able to actually take 110% of the spindle load. That's saying that, it could easily work in as a replacement for aluminum. Metal replacement is a massive area for using these 3D printers. And why 3D print using plastic? Well, of course, you're not gonna cut metal. You're gonna have the part lightweight, and you're gonna print parts faster, which means you're gonna make more money, right? At the end of the day, that's the whole point of having a 3D printer in-house. Right. Next slide. Um, I like to talk about this specific application in the railway sector. So sheet metal bending is a very traditional manufacturing process that's been used for years. You have a bunch of tools and a brake press, and you bend a piece of metal into a shape that you want it to. So why do that when you can just 3D print the entire part in one go on the ARGO 1000? Um, some customers might say, okay, I could make many parts using a sheet metal bending a machine, but what about legacy parts? So if you have a older train or older aeroplane, and your supplier doesn't exist anymore, then you're kind of like stuck. So you could use a 3D printer to actually 3D print these parts without worrying about traditional tooling, and you could technically make them much faster and also cheaper. As you can see over here, the production cost is significantly cheaper, and the lead time goes from three days to a day basically. So that and the secondary thing would be using the right type of materials. So in this specific application, we use Ultim 9085, which has all the right certifications required to actually install this part right back on the train. That's the biggest advantage of the ROBOZE platforms. You have the right machines along with the right materials that eventually are certified to be used on the right a real world application. Right. So next slide. I'd like to talk a little bit more about tooling. Tooling is a massive space for the ROBOZE platform that's where really the value add can be seen. As you see on your right over here, we have a 3D printed aluminum press mold. So you have a sheet of aluminum that sits on top, use a press, goes down, you get your shape, right? Originally, you would have to machine that tool. Over here, we 3D printed. It's 50% lighter and super safe to move around. You're not using a CNC again. That saves up your CNC time, and then it's almost half the cost. And I got to tell you, this part that I'm talking about that you see over here on the right was actually 3D printed on the ARGO 500, which is a filament-based 3D printer. If you were to actually 3D print this on the ARGO 1000, it would be 40% cheaper than the price that you see over there. So we're looking at reduction in production time, not just within like the original production process, which was CNC, but between platforms. So the Argo is much faster. The Argo 1000 is much faster than the Argo 500. In terms of does this work for the application? Yes, we were able to put up to 60 tons of compressed force on this, and it worked out fine. That's a great application that I personally really like. So next slide. Let's talk a bit more about other things that you can actually manufacture on the ROBOZE Argo platform. Thermoforming tools. So anything that requires a higher temperature and a plastic tool is a great space for this. Molds. What you see right in the middle of the screen is a rubber injection mold. So you're actually passing a liquid rubber at a high temperature and high pressure through these 3D printed parts. It can also be used as a replacement for the metal tool. So in case you have a tool that's broken, you don't want to avoid downtime, you can just 3D print your broken component and you're still running your injection mold. So it's a sweet spot for that type of application. And you can obviously also use Ultim to create your forming chucks for sheet metal application. So as you can see, the whole world of applications on the ROBOZE Argo platforms are so wide. It really depends on what you're trying to achieve because the materials have such robust properties. Right. So next slide. I'd like to talk a bit more about metal part replacement and consolidation. What you see on your right is a Ultim 3D printed part, and why for an aerospace application, and specifically Ultim because it passes the flame test, toxicity test, and these parts can fly. They are mostly non-structural, but they can be used as internal casings, covers, things like that. So what you see on your right is the 3D printed part, and right below it is the actual metal part, which was cut, bent, and welded. So that's three different steps, and I believe also stamped to actually get it. But you were able to 3D print the entire thing in one go on the ROBOZE Argo platform, and then that part could be certified and put on a plane so that it can actually fly. So you're talking about a cost saving across all these manufacturing processes and above all, a time saving process too. Then. So next slide. Um, I put this slide in there primarily to give everyone an idea of the whole world of applications that you can actually make. We're seeing chain slide covers, cores for sand castings, work holdings, busbar supports, and a very neat application that I really like, a profile gauge for sheet metal. So if you have a sheet metal bending application and you really need to fit it correctly, you could 3D print the work holding for sheet metal and use that on the Argo platform. So there's so much you can actually do with these 3D printers, and we're here to help you identify those applications, develop them, and then match them to the right platforms that exist with us. So thank you for being here, and that's my time here.
All right. Thank you, Axel. Excellent job. Just a quick recap. So obviously we're here to talk about ROBOZE and the Argo 1000 HYPERMELT. As you could kind of seen in one of Levi's introductory slides, these are a lot of big names using this. He mentioned the F1 teams. This is being used in a multitude of different industries. Um, they carry over a dozen materials from standard to techno to super polymers. The Argo 1000 HYPERMELT is really perfect for large production prototyping. It's got a build size of 1 meter cubed. Apologies for the typo there. And the proprietary technological ecosystem that comes with ROBOZE. The patented beltless system, the PLC, and the insulated heated chamber. All these things are incredibly unique to ROBOZE, and they set them apart. Then, as most of you are on the subtractive side, we see a lot of apprehension to get into the 3D printing to the additive side. Axel mentioned this a bunch of times. If you have machines that are creating work holding just day in and day out, you can be printing these things so you can refocus those machines on production runs, get more parts on and off an extra machine out the door quicker, more jobs, more money. You can print these things quick. You can use them for R&D. It's a wonderful substitute for metal due to its lightweight nature. It has similar tensile strengths, and it's really strong enough for what you need. Heavily regulated industries, aerospace, railway, as we saw. There are multiple certifications that ROBOZE has acquired to make sure that you're able to operate to the requirements that are set for you. And overall, it's a complement to your existing process. It's not meant to replace your traditional subtractive processes. So if you are interested in what we've talked about today, you can send us your part files. We can print them for you as a test run, analyze them, kind of get you in the right application, right machine. We're as a company, we're not necessarily here to do your production runs, but we really want to prove out your part before you go down the road of acquiring a piece of equipment like this. A lot of people actually outsource 3D printing. That's incredibly popular. That takes a lot of things out of your control, sending it outside of the walls of your building. It adds time. There's back and forth with the supplier. And then after a little while, I love this quote from Henry Ford. If you need a machine and don't buy it, then you ultimately find you paid for it and still don't have it. So if you buy the machine up front, you're gonna end up saving money, time, hassle, over the long run. So where to find us? Our website is CAD-CAM.com. I encourage you to sign up for our newsletter. As the marketing person, that's my shameless plug. You can find ROBOZE at roboz.com. We also have a dedicated area on our site for everything ROBOZE. Want to email us? You can either fill out a form on our ROBOZE page on our website or email us at marketing@cad-cam.com. You can find both companies across all your popular social media platforms. This recording will be put up on our YouTube page, so you can send to your coworkers, friends, spouses, if you truly want to, whatever. It's going to be put up on our new channel within our YouTube page called CAD-CAM TV. This has been launched probably about 6 months ago, where we're pretty much giving you free tips and tricks on the products we offer. So we're posting those out there with short video releases. We put our webinars up there. It's really to educate and make you better at what you do. Then, of course, refer back to that machine design article by going up to their website if you're interested in the process we went through. As traditional subtractive folks ourselves, we were tad skeptical of additives, and we wanted to put it to the test, and we were pleasantly surprised. A couple upcoming events. In the next few days, we are going to create and publish the registration for our rollout. It's going to be September 4th at Gossiger West in Cypress, California, 9 a.m. to 3 p.m. We also are going to host that virtually through our YouTube channel. We know it's not always easy to get out of your shop in the middle of the week. That's a Thursday, I believe. So if you want to catch it online, you can do that as well. Now, of course, if you come in person, we're going to feed you. You get the direct interaction with our experts and walk away with some cool swag. So there's some added incentive there. And the facility is wonderful as well. So you can go in there and check out what they have. After that, we'll be at West Tech, which is now called the Manufacturing Technology Series West. That will be October 7, 8, and 9 in Anaheim. You'll also be able to get a free pass once we get that up on our website and social medias. If you're interested in going to that, save you $50 if you use our link. So that being said, thank you everybody for coming. We appreciate it. Thank you, Levi. Thank you, Axel, for your expertise. If we have any questions, you can type them into the chat, and otherwise we'll get you out of here a few minutes early.